वेलकम टू द यूट्यूब चैनल। हमने इससे पहले 12th चैप्टर इलेक्ट्रिसिटी के 11 न्यूमेरिकल्स कर रखे हैं जो आपको प्रीवियस वीडियोस में मिल जाएंगे। आज हम 12th से स्टार्ट करेंगे और बाकी के न्यूमेरिकल्स ख़त्म करेंगे। मैं बच्चों से रिक्वेस्ट करूंगा, स्टूडेंट से रिक्वेस्ट करूंगा कि वो साथ ही साथ न्यूमेरिकल्स करते जाएं ताकि उनको ईजी पड़ेगा। विल स्टार्ट विद द क्वेश्चन। द क्वेश्चन इज that several electric bulbs are arranged to be used on a 220 volt electric supply line are rated 10 watt power. That means जो हमें अगर अपन सॉल्यूशन अगर यहाँ से स्टार्ट करें, we are being given power of each as 10 watt. 10 watt का पावर दे रखा है and voltage is being given as 220 volt. नाउ हमने इससे पहले भी जो न्यूमेरिकल्स थे उसमें किया था कि जब भी हमें कोई बल्ब दे रखा हो या फिर कोई भी अप्लायंस दे रखा हो और हमें उसका पावर या वोल्टेज दे रखा हो, देन फर्स्ट थिंग दैट वी हैव टू डू इज दैट वी शुड फाइंड आउट द रेजिस्टेंस. नाउ अकॉर्डिंग टू द फॉर्मूला P इज इक्वल्स टू V स्क्वायर बाई R. तो इसमें से अगर हमें रेजिस्टेंस निकालना हो दैट वुड बी V स्क्वायर अपॉन P विच कम्स आउट टू बी 220 square upon power is 10, which is equals to 4840 ohms. नेक्स्ट जो अपने को दे रखा है वो ये है that how many bulbs can be connected in parallel with each other across two wires of 220 volt line if the maximum allowable current is 5 ampere. Now we are also given that max current, that is I, is given by 5 ampere and again voltage is given as 220. Now from this we can find out that what would be the total resistance of the circuit, because current जो maximum जा रहा है वो पूरे circuit में जा रहा है, voltage हमें दे रखा है. So from Ohm's law, which is V is equals to IR. If we find out R, we get V upon I, which is 220 by 5, which is 44 ohms. So from this we have got the power. From the power we have got the resistance of each and every lamp as well as or each and every bulb, and we have also got the total resistance. Now this total resistance can also be written as equivalent resistance, and since all the bulbs are connected in parallel, we can write this as RP. We have done in the derivation in which हमने इसको डिनोशन दिया था RP का. So our RP is 44 ohms. So from the formula of total resistance or equivalent resistance, we can write 1 upon RP is equals to 1 upon R plus 1 upon R plus 1 upon R till x times, if we are having x amount of bulbs. Now जो हमें आगे दे रखा है वो ये है that we have to find out what would be how many there are bulbs inside the circuit. तो now formula में अगर अपन वैल्यू सब्स्टिट्यूट करें तो we are getting 1 upon 44 is equals to 1 upon 4840 plus 1 upon 4840 till x times. This can be written as 1 upon 44 is equals to x upon 4840. From this you can write x as 4840 upon 44, which comes out to be 110. Therefore you can write that there are 110 number of bulbs in the circuit. Now comes question number 13. The question is that a hot plate of an electric oven connected to a 220 volt line has two resistance coil A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the currents in the three cases? Now, what we are given is that we are given that the resistance of each coil is 24 ohm. We are also given that the potential difference is V is equals to 220 volts. We have to find out what would be the current in three cases. First one, when they are connected separately. Second, when they are connected in series. And third, when they are connected in parallel. So we'll take three cases. Let us take the first case when they are connected separate. Now it is given that resistance of each is 24 ohms. We are also given voltage, so we can find out current by Ohm's law. Which is V is equals to IR. From this, I would be V upon R, which comes out to be 220 upon 24, which is approximately 5 upon 6 and equals to 9.16 ampere. So this is the answer of the first case. Second, we will consider that when they are connected in series. Now, when they are connected in series, what we need to consider is that the total resistance would be equals to R1 plus R2, which here is 24 plus 24, which is 48 ohms. So resistance in this case would be 48 ohms. So applying Ohm's law, V is equals to IR. From this, I would be V upon R equals to 220 upon 48, which is 55 upon 12, which is 4.58 ampere. So this is the answer of our second question. Now we'll consider the third case. When they are in parallel. Now total resistance then is given by 1 upon Rp is equals to 1 upon R plus 1 upon R, which here is 1 upon 24 plus 1 upon 24. This comes out to be that our Rp is 12 ohms. Now Rp we have got as 12 ohms. We can find now from Ohm's law that V is equals to IR. Therefore, I is V upon R, which is 220 upon 12, which is 55 upon 3, and this is 18.33 ampere. So these are the three answers of three separate cases in which when they are connected separately, the current is 9.16 ampere. When they are connected in series, the current is 4.58 ampere, and when they are connected in parallel, the current is 18.33 ampere. Okay, so now let's do the 14th question. In this, we are given that we need to compare the power that is being used in a 2 ohm resistor in two cases. The first one is that when a 6 volt battery is connected in series with a 1 and 2 ohm resistor, and when a 4 volt battery is connected in parallel with a 12 and 2 ampere 2 ohms resistor. Now we'll start with the first one. The first one says that we have been given the voltage or the potential difference as 6 volts. Now, in this first case, the 1 ohm and 2 ohm resistors are in series. They are connected in series connection. Now, since they are connected in series connection, the total resistance would be 1 plus 2, that is 3 ohms. Okay, so this is the first step that we need to do, that we need to find the total resistance that would come out to be 3 ohms. Now we need to find power, and for power we would also be requiring what would be the current. So from Ohm's law we can say since V is equals to IR, I would be V upon R, which comes out to be 6 upon 3, that is 2 ampere. Now, since it is a series connection, we need to find the power. Power can be written as I square R in this case. Now, for going through the formulas that we had of power, we had power as I square R, we had power as V square by R, and third we had power as Vi. These are the three formulas that we can use as and when required. Here we are having that it is in the series connection, and therefore the current going through both the resistance would be same. That is why we are taking the formula of power as I square R. From here, we can say that power would be 2 square into the resistance has to be found for 2 2 ohm resistor. So that comes out to be 4 into 2, that is 8 watt. So this is the answer of the first question, that when a 6 volt battery is connected in series with a 1 and 2 ohm resistor. Now we'll do the second case. In this, the voltage is given as 4 volts and the resistors that are connected in parallel. Now, what we need to understand is that since the voltages are connected the resistors are connected in parallel connection, therefore, the voltage across all of the resistors would be the same. So, we can directly use here the formula of power as P is equals to V square by R, because V will be same. So voltage is given as 4, resistance we need to find for 2. So this comes out to be 16 by 2, that is 8 watt. So the power used in both the cases would be the same. We just need to understand that which formula we need to use. In the first case, we use the formula as I square R, as the resistors were connected in series, and in series the current is same. So we could use the formula I square R for power. In the second case, the resistors were connected in parallel connection, and we know that in parallel connection जो वोल्टेज होता है दोनों रेजिस्टर्स का वो सेम रहता है, एंड देयरफॉर वी कैन टेक द फॉर्मूला ऑफ पावर एज वी स्क्वायर बाय आर. आर की वैल्यू हमें दोनों में सेम लेनी है. दोनों केस में जो वैल्यूज चेंज होगी वो फर्स्ट केस में अपन फॉर्मूला लेंगे आई स्क्वायर आर, और दूसरे में अपन फॉर्मूला में लेंगे वी स्क्वायर बाय आर. सो दिस इज द आंसर ऑफ आवर 14th क्वेश्चन. Now our next question, that is 15th one. We have been given that two lamps, one rated 100 watt and 220 volt, and the other as 60 watt and 220 volt, are connected in parallel to the electric main supply. What would be the current drawn from the line if the supply voltage is 220 volt? Now, from what we get from the question is that there are two lamps, they are connected in parallel, and the voltage supplied is 220 volt. Now, Just take a look that the voltage in both the cases is same just because they are connected in parallel. Therefore, in both the cases the voltage are given as 220 volt. Power is given different because the amount of current flowing through both of them would be different. So we'll do the sum, take the solution. We have been given that in first lamp power is equals to 100 watt and voltage is 220 volt. We can use the formula of power as P is equals to VI to find the value of I, that would be P upon V, which comes out to be 100 upon 220, which is equals to 0.455 ampere. For the second lamp, again P would be equals to VI, and here I again would be P upon V, which would be equals to 60 upon 220, which comes out to be 0.273 ampere. Now we need to find out what would be the net current drawn from the supply. Now since it is a parallel connection, the total current, since it is a parallel connection, total current I would be I1 plus I2. We can give the name here as I1 and I2 so that it's easy to remember. Now, total current would be I1 is 0.455 and I2 is 0.273, which comes out to be 0.728 ampere. So this is the total amount of current in the circuit. Next is question number 16. The question says that which uses more energy, a 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes. We have to find out energy, and we know that the formula of energy E is always P into T. Now power, in both the cases we will find out one by one. The first case is of a TV in which energy would be power is given as 250 watt into time as 1 hour. Now since energy is always found in joules and joule will have time in seconds, convert to 1 hour into seconds, which comes out to be 3600 seconds, and the answer here would be 900,000 joule. This would be the energy that would be consumed by the television set in 1 hour. Second, we are asked of a toaster. Your energy would be, we are again given the power as 1200 watt and time as 10 minutes. Again you have to convert this into seconds, so you are getting this as 10 into 60 per seconds, and here the answer comes out to be 720000 joule. Therefore we can say that energy is used more in TV than in a toaster. So that's your answer for question number 16. Okay, so 17th question, it states that an electric heater of resistance 8 ohm draws 15 ampere current from the service mains for 2 hours. Calculate the rate at which the heat is developed in the heater. Now, what has been given is that the resistance is equals to 8 ohms, current is equals to 15 ampere, and time that is given as 2 hours. We have to find out what would be the rate of heat. Now heat is given as I square R T according to Joule's heat or Joule's law. Rate of heat would be H upon T, which states I square R T upon T. So your T gets cancelled and you get it as I square R, which is I is given as 15 and R is given as 8. So you get this as 1800 joules per second. Per second, because we need to find the rate. So this is the answer of 17th question. The 18th question is theoretical question. So here we finish the chapters numericals for electricity chapter number 12.